Now, the very nice thing about this technology is that it's a really good example of pure physics. Okay? We're using fundamental physics, fundamental ideas in physics about how we manipulate electrons to produce light. And light comes along in packets we call photons. So this whole field is called photonics. Okay? But it's built around these building blocks, these lasers, and these find their way into lots of applications, and I'll talk about those as we go through. So the key idea here was to basically make this very thin layer under strain. So you squeeze the material into that layer, and it basically allows you to emit light very efficiently. The idea was really radical, and at the time, industry didn't want to do it. Okay? It was too radical, and it was a bit of a risk. Okay? So it was a perfect example of scientific and academic research, okay, to take it forward. So it was initially considered a risk, but these things are now sold in their billions and produced in their billions. So here's a picture of that laser again, and just to show you where it comes from. So these are grown, actually. We grow lasers, you'll be interested to know, and I'll tell you more about that if you come to the stand. And there's a wafer, and we have, on a wafer, typically of the order of 30,000 of these, okay, that we can produce. The wafer's about this big, okay? And each one of those lasers could either end up it could be a laser pointer, could be a laser that we use for driving the internet, in your CD player, DVD player, and so on. So let's look a bit more at applications. Where does this technology end up? So I guess the one that we're most familiar with is storage. So if you actually think about your home, you'll find that there are probably, I wouldn't be surprised to know if there was something like 10 strained layer quantum Hall lasers in your house. You probably don't know that, but they're there, okay? And so examples could be in your DVD player, so that's actually Blu-ray, and one of the nice things about strained layers is that we can actually manipulate the color of the light, and as we go to what we call shorter wavelengths towards the blue, we get higher storage. So the technology for data storage, optical data storage, started with CDs, and it moved all the way down to these things called Blu-ray discs. Okay, so that's a nice example where we use a blue strained layer laser. Onboard aircraft for optical communications. Okay, so using optical fiber communications onboard aircraft is useful for reducing noise. Onboard cars, in-car systems for controlling various systems onboard cars. That happens to be a BMW there. Inside laser printers, laser pointers, obviously. Surgery, okay, so diode lasers are often used to pump lasers that produce even more power, and we'll hear about those in the next talk. And so surgery, field surgery, for example, they're very useful for that. Barcode scanners, something you take for granted at the supermarket or used in warehouses, speeds up things enormously. And at the heart of that, there's a laser, a strained layer laser. Okay, so that's enabling that kind of technology. Optical fiber connections, you might not realize that inside things like your hi-fis now it's optical. Okay, so we're using light to transmit information very quickly and very efficiently. And behind that, there's a laser. Okay, so, and of course, there's a picture of the internet, and I'll talk about that in a moment. And finally, a mouse. If you've ever seen a laser mouse is called a laser mouse because inside there's a strained layer laser. Okay, and these things are making it mice, optical mice, extremely useful, and you can use them on very varied surfaces. So overall, there are lots and lots of different applications here. These are just a few, really. Several market areas they end up in. And they've really enabled a lot of technology. I guess probably the biggest one is the internet, okay? And it's been called mankind's biggest machine. And the internet is a very good example of technology being developed in the UK, okay? And it's British technology that really has driven the internet. It's really nice to say that. So there are two things that have really led to the internet. One is the laser, and the other one is the optical fiber. And so this picture here, it just shows some of the optical fiber routes that exist in the world that are linking the world together. And of course, the other nice thing, as we heard in the last talk, we heard about Sir Tim Berners-Lee in terms of information and data, but he actually came up with the concept of a World Wide Web. Okay, so one can argue quite reasonably that the internet itself is an entirely British invention. Okay, so we developed the hardware and we developed the software. I'm sure there are some people that might argue that, but there you go. But industrial impact, as I said earlier, it was considered a high risk to industry because, to be honest, industry doesn't have the bandwidth often to investigate ideas that are radical. Okay, so academic research is really, or academia is where we can really try out new ideas that you can't really do in industry. And they can have a big impact, just like the strained layer laser. if we look at the UK, the impact of this has had hits all areas of industry, and you can look at the whole supply chain. So we have companies down here that make chemicals, okay, so the chemical industry, white semiconductor wafers, companies that actually make the devices, and then users like the telecom providers and so on. So you can see that it really does impact across the full bandwidth of industry, really, from fundamental chemistry, material science, all the way through then to it being used in a network environment. The market size for photonics, the overall area that this fits in, and as I say, lasers are the enabler for photonics, is enormous. And this is actually a few years old now, this data, but we can see that the value to the UK is substantial, and the total world volume in terms of photonics is enormous, okay, measured in the hundreds of billions. So really, it's a key technology. But where's it going? I should talk about where it's, I've talked a lot about what's happened and why it's important, but where is it going, okay? Well, I guess the key areas, really, where this will play a significant role are in energy, environment, and security. And they are very important areas. So, for example, security scanners. Okay, so you might have already seen some terahertz scanners at airports, but to develop cheap scanners that work well at room temperature, which tends to be where people need them, we're developing laser technology to actually target that. Okay, and that's a nice image that comes shows how you can image someone that's holding a knife just by looking at them in a different wavelength region. Also, replacing lighting. So if you look at LED lighting, LEDs contain strained layer quantum wells, okay? And that's fundamental to, engineering those is fundamental to making efficient solid-state lighting. So it comes in there. So how we use energy. And of course, lighting is a major use of energy. So if we can put these layers in there, then we can really reduce energy use. Optical computing, replacing our computers with optical forms of computing. So the one thing you'll notice about your laptop is that your lap gets hot, okay? And that's because of all the electronics inside that's warming things up. Well, you want to be able to do that optically. It'll be faster, more efficient, and that requires lasers. And that is really a technology that's developing. Environmental and health pollution monitoring, those kind of things. Again, we can use optical approaches using these lasers to actually sense environmental pollutants. Okay, so gases in the atmosphere, we want to be able to monitor them. And because these lasers are so small, we can maybe embed them in things like mobile phones. Okay, and then you have a network telling you about the gases that are in the atmosphere and the pollutants and where they are and so on. And finally, energy generation. Again, think radically. How can we generate energy? And so at the moment, we're working with Astrium to look at how do we harness solar power more effectively? How can we make solar power available in the day or the night time? Okay, and that requires using photovoltaics, which are used to convert light into energy, into electrical energy, but also we can use lasers to help transport it around the planet to where we need it most. So I think there are some areas there that we're working on at the moment, and hopefully you can see it's already had a big impact, and it's going to have a bigger impact in the future as well. So with that, I think I'll close. Thank you.